Hello everyone! Today our team will tell you about a photography technique called autochrome and present a way of chemical modification of this technique. The method that we propose make it possible to see what is invisible in traditional photos. As we know, ultraviolet rays negatively affect the internal structures of a human eye, the lens and retina, provoking the occurrence of various ophthalmic diseases. Our eyes have natural protection from UV rays, cornea and iris. Nevertheless, the ultraviolet world is very interesting and bright. For example, a photo in the ultraviolet range allows us to see details with more contrast. The goal of our project is to propose a system which will be capable of depicting UV light on the photo using the principles of the autochrome process. Before talking about principles of the autochrome process, let me talk about history of the first color photo. The autochrome is a process of photographic restitution of colors, patented in 1903 by the brothers Auguste and Louis Lumière and developed by Gabriel Dublier within their workshops. It is the first industrial technique of color photography. It produces positive images on grass plates with colored grains of starch on them. One of the most broadly used forms of color photography in the early 20th century. Autochrome was recognized for its aesthetic appeal. The photos really do look stunning.
Autochrome color process is one of the first color processes. It is based on the additive color synthesis due to a color raster made of colored starch grains. After the exposure, the photographic plate is developed and reversely bleached, giving the positive image. This positive image appears to be colored due to the color raster acting as a light filter. For our goal, we propose to depict UV light as a pseudocolor. To achieve that, we are going to make the pseudocolor pixels opaque to the visible light, and all the other pixels opaque to the UV light. This will ensure that UV light is transmitted only to the pseudocolor areas of the image. The starch for the raster is treated as follows. Starch grains are dyed in the aqueous mixture of organic dyes. Then they are washed with ethanol to remove the excess dye and prevent the mixing of colors. This gives us grains of different color that will later act as a light filters. To make colored starch particles opaque to UV, we've decided to coat them with UV blocking substances. Two of them are dibenzylidine acetone, or TBA, and zinc oxide, both of which are used in various sunscreen products. DBA is soluble in organic solvents and can be applied to starch particles as a solution. Zinc oxide is a very fine powder and thus would be able to coat much larger particles of starch. As seen from light absorption spectra, both compounds efficiently absorb UV light. Due to the difficulties in the synthesis of DBA and coating the particles with it, we've decided to use zinc oxide. As seen from the comparison, zinc oxide coating indeed makes starch particles opaque to the UV. To make raster plate, we've coated a transparent plate with rubber-based varnish, then sprinkled the mixture of colored starch particles over it and pressed, thus creating a color raster needed. So, to make a conclusion, we have obtained a functional color raster which can be used to depict UV light as a pseudocolor. Although we have not obtained any images, the evidence given leaves no doubt that it's possible. As a point to improve, it's possible to find another UV blocking compounds which might be more effective. As a possible application, we see a production of unusual photos as a form of art, as nowadays the classical photographical processes are no longer used for other goals due to their complexity and abundance of digital cameras.